remember today when we're simplifying expressions, they're going to have fraction exponents in them. So we have to know how do we treat that. So if I ask you, what is 4 to the 1/2 power? Anybody in here think they know what that is?
2.
2. Okay. How about 16 to the 1/2 power?
8.
Well, 8. Okay.
Actually,
It's 4. It's 4. You think? Okay.
Oh, yeah, it is. It's
Yeah,
4 times 4 is
yeah.
16.
it's
Yeah,
gonna
yeah.
be like 1.
It's gonna be a
Yeah, it's
square
gonna
root.
be.
Oh, so when you're taking something to the 1/2 power, that really means find its square root. Is that what you're saying? Oh, so if I'm taking 81 to the 1/2 power, it would be 9. Okay. Well, then what if I want to take 8 to the 1/3 power?
Well, then it's a fraction.
Yeah, Michaela says it's 2. Why is it 2, Michaela?
Because 2 times 2 times 2 is 8.
Because 2 times 2 times 2 is 8. Or in other words, it's asking you for the cube root of 8 when it's to the 1/3 power, not the square root. It's the cube root instead. Okay? So when we have b, let's just focus in on this one first. So we have b to the 1/n power. That n is the root that they want us to find. Or it's asking us what number times itself that many times, n number of times, is going to get you back to the base. So we're looking for, when we are taking something to a fractional power, we're looking for a root. Okay, we're not looking for that multiplied by itself necessarily, the base multiplied by itself. We're looking for what multiplied by itself gets you back to the base. Okay? So we can see it written as b to the 1/n power, or this might be another way we see it. N in the little crook of the radical sign, and b, the base underneath the radical sign, those two things mean the same thing. They're asking what number times itself, n times. So when you just said, I said, what's 4 to the 1/2 power? You said it's 2. Well, but I think some of you were going 4, half of 4 is 2, and that's how you got it. So then when I asked what's 16 to the 1/2 power, you said 8. Because half of 16 is 8.
But it's
But 1/2, the n value is 2 in a 1/2 power. So we're actually asking ourselves, what number times itself 2 times is the base, or b? So when we are taking b to the 1/n power, we're looking for what number times itself, n number of times, will give you b. Will get you back to b. Okay? Another thing we call n is the index. So if they ask you what's the index, it's really saying which root. Do you want to find the square root? Do you want to find the cube root? Do you want to find the 4th root? Do you want to find the 8th root? What is it that you're looking for of your base? So index and root kind of mean the same thing. Okay? So in square root, what is n? What's the index in the square root? 2. What's the index in a cube root? 3. What's the index in a 7th root? 7. So when we talk about roots, index, we're really talking about the same thing. So let's start practicing here. What's 8 to the 1/3 power? You guys already answered this for me. It's really asking for the 3rd root of 8. Or in other words, it's asking for what number times itself, how many times?
3.
3 times results in 8. So here's how we're going to show our work. We're going to say, oh, I got to find something that multiplied by itself 3 times is going to result in 8. And you said it was 2. So 2 times 2, 2 times 2 again, right? So 2 times 2 times 2 is 8. So we're going to say that 8 to the 1/3 power is 2. Now here's what we're not going to do, because I can't, first of all, I'm afraid you might let the calculator do it when you're not in my presence. And also, the calculator does know how to do it, so why not let it do it? But you have to be the one to know how to do it, because on the quiz, when you're doing these kinds of things, you're not going to get to use the calculator. Could you double check though for us and see, those of you who have a calculator here right now, would you take 8 to the 1/3 power, please, and make sure we're right So we know what we're doing. And if you don't know how to do 1/3 power in your calculator, you might have to treat 1/3. Remember how we do the graphing calculator? Parenthesis 1 divided by 3 parentheses. When we take 8 to the 1/3 power, do we get 2? Okay. So, did we? Of course you don't, because you didn't bring your calculator. Okay.
Yeah, 3 times 2 is 4.
So 81 to the 1/4 power is asking what? What root is it asking for? It's asking for the fourth root of 81. Or in other words, it's asking for what number times itself 4 times is 81. So here's what we would show. We're going to figure out what multiplied 4 times gets us 81. What do you think it is, Hunter?
3.
3. You guys agree?
3 times 3.
3 times 3 is?
9 times 3 is 27 times 3 is 8.
Okay. And is it 9 times 9, 81? And what is 9?
3 times 3 is
And 3 times 3, right? So, must be. I'm feeling pretty good about 3. So 3 times 3 times 3 times 3 does yield 81, so we can say that 81 to the 1/4 power is 3. Okay. Moving on to number 3, now we're finding, we have 2 powers, 121 to the 1/2 power and 256 to the 1/4 power, and we're going to find their sum. So we're adding them together. Well, the first one is asking us for the square root of 121. Isn't that what 121 to the 1/2 power means? So we're really looking for what times what equals 121. What is that, Russell? 11. Okay, so we're going to say 121 to the 1/2 power, also known as the square root of 121, is 11. Now, I wrote these in their other form because I want you to recognize that when you have it written as it is here with the radical sign, notice the 2 is not here, is it? The n value is not there. So when there's not a number in that crook, when there's not an index there, we are going to always assume it is what? What would we have to assume it is if nothing's written here?
B.
2. No, it's always going to be 2. We just don't write it. But when there is a number written there, that means which root you're going to find. So we're looking for the 4th root. Here we're looking for the square root, which is the 2nd root, right? Okay, so 4th root of 256. This is just another way to write that. I'm just showing you, you could be given it either way. You better understand what it means. So we are looking for what times itself. How many times?
4.
4 times is 256.
4.
4? Okay, 4 times 4?
16.
16. 16 times 4?
64.
64. 64 times 4? 256. Okay. Yes. I don't know. How do you know that, Hunter?
He's smart. He just doesn't apply his knowledge like he should.
Listen to your father over there. 4 times 4 times 4 times 4 is 256. Okay, so so the 4th root of 256 is what? The 4th root of 256 is 4. So the square root of 121 is 11. The 4th root of 256 is 4. So 11 plus 4 is 15. Our final answer in this one is 15 because we were finding the sum of some powers. Okay. In our last one, what are we looking for? 27 to the 1/3 power. What are we looking for? 3?
Well, something.
I said, what are we looking for? I didn't say what's the answer. We're looking for the 3rd root of 27 minus the what root of 1? The 5th root of 1. So the 3rd root of 27 means
times 3
What?
times
What multiplied by itself 3 times, and it is
3.
3, the answer you wanted to give me right away in the beginning. So 3 times 3 times 3 is 27. So we can replace 27 to the 1/3 power with 3. 1 to the 1/5 power, we need the 5th root of 1.
1.
How do you know?
Because it's 1.
Why is it
Math.
1?
1 times itself.
Because one time itself is also
Does it matter how many times you multiply 1 times itself?
No.
Will you always get 1?
Yeah.
There's nothing else you can multiply by itself then and get 1 in the end?
no.
Can you take 2 times 2 and get 1 ever?
No.
1/2 times 1/2?
No.
No.
Yeah.
That's not 0.5.
That's 1/4.
That's 1/4.
Yeah.
Is there anything other than 1? So in other words, if I'm asking you to find the square root of 1, it is
1.
1. If I'm asking you to find the cube root of 1, it is
1.
If I'm asking you to find the 10th root of 1, it is 1.
1.
If I'm asking you to find the 5th root of 1,
1.
it's 1. That's always going to be 1. So anytime you're doing that, you're going to be like, you know what, I don't really need to show work for that one because no matter what root I'm looking for a 1, it has to be 1. It has to be 1. It's kind of silly to have to show all the work. 3 take away 1 is
2.
2. So our final answer for that one is 2. Okay, note before you turn that over, every single one of these powers that we were working with had a fraction exponent. What was true about the numerator in all of them?
There were 1.
It was 1. So when the fraction exponent has a numerator of 1, this is what we get to say. I am looking for the, whatever the denominator is, I am looking for that root of my base. Okay? What happens though when we do flip our papers over and it says when the fraction exponent has a numerator, that is a whole number greater than 1. It can be written as a what?
Power to
Power.
Power to a power. We just talked about this yesterday. A power to a power. What happens when you are taking a power to a power? What do you do to simplify it? You subtract? Subtract those exponents? Add those exponents?
You do. Or
You
multiply.
multiply them. Remember, when it's a power to a power, you multiply them. So b to the fraction m over n power can actually come from this. Do you agree? Do you think b to the m over n power can be rewritten as b to the 1 over n power, and then that to the m power as a power to a power? Why? Why can we do that?
Yeah.
Okay, because they touched that yesterday? That why?
Yes.
Huh, yeah, well thanks for being here. 1 over n times m, would that get us back to b to the m over n power?
Yeah.
Okay, would. So that means we can now take a fraction that does not have a numerator of 1, it has a numerator greater than 1, and we can first take our power and rewrite it as a power to a power. And then we'll be able to say, now we're looking for the nth root. We're looking for the nth root of a number, which is going to be, that number is going to be b in this case, raised to the what power? M power. So we're first going to find the nth root of our base, and then we're going to take that answer and we're going to raise it to the numerator's power. Whatever the numerator is, that's the power we're going to raise it to. So these get a little bit, more, they're a little trickier. We have a little bit more work to do. So number 5, 16 to the 3/4 power. Look at how I said we could rename that as a power. What happened? How did I get it from 16 to the 3/4 power to 16 to the 1/4 power raised to the 3rd power?
You take it times
Where'd the numerator go? To the outside, to the power on the outside. And what did that numerator get replaced with? A 1. Is 1/4 times 3 3/4? So in other words, We can rename it like this, can't we? So we're first thing we're gonna look for is we're gonna evaluate what is 16 to the 1/4 power. 16 to the 1/4 power means what times what times what times what equals 16.
2.
That is 2, okay? So the fourth root of 16 is 2. So now we're going to replace this part right here with a 2. That's what we just found. And we're going to take it to the third power. Hunter?
Equals 8.
It equals 8. So 16 to the 3/4 power is 8.
So our answer would be 8.
Okay, I want you to take the next one. I want you to the only thing I want you to do is rewrite it as a power to a power. Only step I want you to take right now, I want you to make sure that you know how to rename that as a power to a power. Okay, Mara, what is it?
25 and 1/2
To the,
to the 1/2 power to the third power.
and we're going to take that, raise it to the third power. How many of you agree with Mara? This is the way we should rename it as a power to a power. In other words, when you're done naming it, if you multiply those two exponents together, would it take you back to the fraction you started with? Is 1/2 times 3, 3/2. Okay, so it works, doesn't it? Okay, so that means now that we're going to say, okay, I'm first going to deal with my 25 to the 1/2 power, which means what? Something times itself, how many times? Twice gives you 25. And that's 5, okay? So we have 5 times 5 is 25, so 25 to the 1/2 power becomes 5.
To the third.
And now that 5 has to be raised to the third power. Hunter,
125.
you are just a calculating machine. 125.
That one was easy though.
Well,
Because it's a 5.
okay, tell me something about, that number is bigger than what we started with, 25. But yet in number 5, 16 to the 3/4 power ended up 8. Less than 16. On the front side, what happened? Every time we were taking something to a power that had that 1 in the numerator, did we end up with simplified answers that were greater than our base or less than our base? Less than, okay? And that's what happened in number 5. We ended up with a number less than our base. 16, we ended up with 8. That's less than 16. But this time, we ended up with something bigger than our base. Why do you think that is, London?
Because 3/2 is greater than 1/2. So
3/2 is greater than what?
1/2.
Than 1. Yeah, it's greater than 1. What is 3/2? 1.5, isn't it? So we're taking it to a power greater than 1. When we take it to a power greater than 1, what do you think we can probably predict is going to happen? Yeah, we're going to end up with a number bigger than our base. If our power is less than 1, it's somewhere between 0 and 1, what do you think we can predict should happen? We better be smaller than our base, right? So what do you think is going to happen in number 7? 27 to the 4/3 power. Is the answer going to be smaller than 27 or larger than 27? Larger, because what?
Because the denominator, or I mean the numerator is
Bigger than the denominator.
Which makes the fraction
bigger
bigger than 1. There you go. Okay, so
Such a smart.
let's see. Aaron, I need you to tell me what 27 to the 4/3 power is renamed as a power to a power. 27 and 1/3. 27 to the 1/3 power. We're going to learn how to say this right. Come on, we can do it. 27 to the 1/3 power to the 4th power. There we go. Do you guys agree?
Yes.
Okay. So then that means what? We're going to find, first of all, we're going to find out what 27 to the 1/3 power is.
3.
that is something times itself 3 times, which is 3, okay? So 27 to the 1/3 power became 3, and that has to be taken to the 4th power, so Hunter, what's that? 81. Did what we think should happen, happen?
Yes.
Okay. Hopefully you're starting to see something that you're like, you know what, I think I could even predict what 27 to the 5/3 power would be without having to work too hard. Anybody have any idea what they think 27 to the 5/3 power would be?
5.
I don't know, just tell me what you think it's gonna be.
243.
27 to the, not with your calculators, or what is it?
243.
And how do we get it really quickly?
Calculators.
3 times 8 is 24, and 3 again because
So we just did one more
Step.
step, didn't we? Instead of taking it to the 4th power, we would have to take it to the 5th power, so we just have to multiply by 3 again, wouldn't we? So it would be 81 times 3, which is 243, which is I think what you were trying to tell me you were doing, is multiplying 81 by 3. Okay. Okay, let's look at 1 to the 4/5 power. 1.
Anything times 1.
Could you just tell me what it is renamed as a power to a power? 1 to the 1/5 power. Let's at least practice that. So this is 1 to the 1/5 power. That is raised to the 4th power. Okay, we know that 1 to the 1/5 power is 1. So that becomes 1, and now we're going to raise that to the 4th power, and that becomes 1. Oh, you guys were so smart. Okay. 1 raised to any power then?
1.
Whether it's a fraction, or a whole number, or 0, or a negative, it's always going to be 1?
Always.
Always, okay.
Unless
Unless there's a
negative.
zombie apocalypse.
How about 1 to the negative 3 power?
1.
No, that'd be 1 over. Wait, that'd be 1 over 1.
Would it be negative?
1 over 1 is 1.
1 over 1 to the 3rd power.
1 times itself 3 times 1.
Yeah, I guess that would be 1.
Wait a minute, I have to, Nick says 1 to the negative 3 power means negative 1 times negative 1 times negative 1, and if you take a negative times a negative times a negative, you get a negative. Is that what 1 to the negative 3 power means? Take
No.
negative 1 times
No.
itself 3
No.
times? Yeah, it's going under, it's becoming a 1 over 1 to the positive 3 power.
Which is
Well, 1 to the positive 3 power is still 1, and 1 divided by 1 is. So do you think there's any possible power we can take 1 to that we will not get 1?
No.
10.
No.
0.
Do you get another
No, you
class
still get
early?
one.
Negative 1.
1 to the 0 power is not 1?
Yes,
It's
it
1.
is.
Okay, well. Until when you come and you have no work shown for these and you say to me, well, it has to be 1. Well, then you're going to have to be convinced that no matter what power you take 1 to, you will get 1. Whether it's a negative power, a positive power, 0, a fraction, I don't care what it is. Any number from the number line, it better give you 1 then if you're not going to show me work.
Okay, okay.
Huh. Okay. How about 0?
1.
0.
0.
1.
0, no, that's fine. 0 taken to any power.
0.
It'll always be 0.
Yes.
So 0 to a negative power?
It'd be 1.
0 to a negative 2 power?
Well, it'd be
1
0.
over 0 2 with 0
It'd
times
be
0.
1 over 0 squared.
Yeah.
And can you, what's 0 squared?
1.
Can you divide by 0?
No.
Oh, how about 0 to the 0 power?
0.
Really?
1.
It's 1.
Really?
It's 1.
Oh.
Now I'm
No,
confused.
0.
Sunday fine.
Yeah.
Oh,
Just remember you guys, 0 to the 5th power is,
0.
0 to the 4th power is,
0.
0 to the 3rd power is,
can't divide by zero.
I thought it was one.
No, zero's the only one, remember? Any non-zero number taken to the zero power is one. Non-zero number. So what do you think 0 to the 5, 6 power is?
Oh.
Zero. Zero. It's 0. Oh, because this would be 0 to the 1 6 power, which means what times itself 6 times is 0? What times itself 6 times is 0? 0. And 0 to the 5th power is 0, so the answer is 0. London.
Undefined.
For number 10.
Oh, yeah.
Yes, we are.
We're going there now.
Rename the power.
Can we rename the power?
Yes.
4
Yeah.
over 2.
Okay.
We just did that in
So
five.
So what do you want to rename it to? 4 over 2? The power? If it's 4 to the 2.5 power, it's 4 to the 2.5 power, can we rename that 2.5 as an improper fraction so we have an m over n?
Yes.
Yeah. It would be 4 to the 5/2 power, right? Yeah. Which means then we're going to take 4 to the what power?
1/2.
1/2 power, and then we're going to do what with that?
Take that to the 5th.
Take that to the 5th. So we're really looking for the square root of 4, and we're going to take that to the 5th power. Isn't that what we're doing when we take 4 to the 1/2 power?
Yeah.
We're looking for the square root of 4. What is the square root of 4? 2. So this becomes 2, and that's going to get taken to the 5th power. And 2 to the 5th power is 32. Okay, page 399 in your books. Go there now. Got your notes.
399.
That's cheap.
We're going to do the check it out problem at the bottom of the page, but you're going to have to refer to the example above. So go ahead and read quickly. We're doing the check it out problem at the bottom of page 399. And to be able to do it, you need to refer to the example 3 problem above. What is it we're looking for?
Number of calories that a panda needs each day.
Okay, number of calories that a panda needs each day. How are we going to do it?
We need to
So to
multiply.
Z. Are we taking a field trip?
Not today, it's Russell?
And the example is like for to find the calories is C equals 72 average weight.
Oh, so they gave us an equation that will help us. Okay, and this equation is, let's write that down first. We have the equation capital C equals 72 small m to the 3/4 power. Do I have that right?
Yeah.
Okay. Where capital C represents what?
Calories.
Number of calories. Okay. What does little m represent?
Mass.
Mass. Okay.
The parents' mass.
So the panda's mass in this case, we're going to be, okay? So what is it that we're looking for? Are we looking for how much this panda weighs?
No,
Or how much this panda should be eating?
Which it should be eating.
How many calories it should be eating? Okay, so we're not going to replace C, we're going to leave CC. And 72 is going to stay 72. What are we going to put in for M?
81.
81, because that's how much the panda weighs,
Wait.
right? Did we put it in the correct place?
Yep.
Okay. That's good, because I don't know if we can handle solving an equation for M to the 3/4 power. How would we get that 3/4 power out of an M? I'm not sure you guys can do that yet. Okay, now order of operations says take 72 times 81. Or should we take 81 to the 3/4 power first?
81 to 3/4 power.
81 to the 3/4 power. So let's go over here to the side and do that. 81 to the 3/4 power means 81 to the what power?
1/4.
1/4 power. And that raised to the third power. Okay. So we are now looking for what times what times what times what equals 81.
3.
That is 3. Okay. Figured it out. So now we have 3 to the third power,
Which is not.
27.
which
Oh.
is 27.
Oh.
So now we're gonna go back over here and we're gonna say that 81 to the 3/4 power can get replaced with 27. Oh, now we really have to stretch our brain. 72 times 27, no calculator. Russell's got it for us. Oh, thanks Russell for saving the day, because of course we could have counted on Hunter, he's been our calculator. 1,944, is that the year 1944?
Yeah.
He was born in the 1900s.
1944, what, 1,944 calories per calories. We just need a label on it, just calories is enough, okay?
We need more than recommended calories and
Oh,
pandas.
isn't that something? Okay. An 81 kilogram and
How much is it? How much?
Okay, any questions on these problems though before I turn out the recording? Anything we need to still have cleared up?
Is this going on YouTube?
That'd be pretty cool.